Door is attached to a frictionless hinge, as in this question here. And it's our job to figure out what happens when a piece of putty is suddenly thrown at it and it sticks to it and makes it rotate. We want to find out what the angular velocity is when this piece of putty gets to it. Well, we would definitely have an I1 omega 1 equals I2 omega 2 question. So I1 omega 1 equals I2 omega 2. That's the conservation of momentum. But as we look at this piece of putty, it is traveling in a straight line. So how do we handle that? Well, let's take a look at I1 omega 1 here again and see what we can figure out. Well, this piece of putty, of course, is a point mass. So we're going to go mr squared for that. That'll get the I for it. Now what about W? Well, remember, W is related to velocity in this fashion here. Velocity equals R omega. So then we're going to say that omega, and sometimes we call it W, is equal to V divided by R. So we're going to plug V divided by R into our equation. And this is what the angular momentum would be, okay, for the piece of putty. So let's see what crosses off here. Well, we have a radius crossing off of this radius squared. And L is then going to equal mass times velocity multiplied by radius. I just rearranged things a little bit, moving the velocity there and the radius over there. So even though this is going in a straight line, we can still consider that it has angular velocity relative to the point of rotation. It looks to me like it strikes the door at 0.12 meters from its end, therefore 0.88 meters from its point of rotation. So now I'm going to change this equation to mvr equals I2 omega 2. Okay, so let's take a look at this here then. So the mass of this putty is 1.2 kilograms. So we're going to multiply that by the velocity, and that's going to be 30 meters per second, so times 30. Now again, multiply that by the radius of 0.88. Now what comprises I2 for this example? Well, once the putty hits it and sticks to it, we'll have a door moving plus a piece of putty in it. Okay, so we're going to need to know the moment of inertia for both of these. So let's look at the I for the door first. Okay, what equation does it have? Well, I for the door is 1/3 ml squared. Okay, and that equation again will be given to you. So I for the door equals 1/3 the mass of 10 kilograms. And it's 1 meter wide, so times 1 squared. So the I for the door then has a value of 3.33 kilogram meters squared. Now let's do the I for the putty. And again, that'll just be mr squared. So that's going to be 1.2 for the mass of it, multiplied by 0.88 squared. And therefore the I for the putty is then going to equal 0.929, and that of course is also kilogram meters squared. So on the right side, my I2 is comprised of both of those moment of inertia since the putty does stick with it. So I'm going to go 3.33 plus 0.929 multiplied by omega 2. And omega 2 is going to equal 7.43 rads per second. Now, if we want to know what kind of collision this is, we're going to look at the change in kinetic energy for this. Okay, the change in kinetic energy will be the final rotational kinetic energy minus the linear kinetic energy or translational kinetic energy of the putty. So then we'll go 1/2 I, which again is 3.33 plus 0.292. We'll multiply by that omega squared, 7.43 squared, minus, again, we'll just do 1/2 mass times velocity squared, so 1.2 times 30 squared. And we get negative 422 joules. Since kinetic energy difference is not equal to 0, we actually lost kinetic energy, this must be an inelastic collision.